Hello students, today's video on light, shadows and reflection in chapter 8 in class 6. Also before starting my lecture like, subscribe and press the bell icon. Let's start. Light. Light is a form of electromagnetic radiation that is visible to the human eye and is responsible for the sense of vision. It is composed of tiny particles called photons that travel in waves. Light can be produced naturally, such as by the sun, or artificially, such as by light bulbs or lasers. It travels in straight lines until it interacts with objects or substances. Shadows. Shadows are formed when an object blocks the path of light, creating a dark area behind it where light cannot reach directly. Shadows are created when light is obstructed by opaque or partially opaque objects. The size and shape of a shadow depend on the position and orientation of the light source, as well as the object casting the shadow. Shadows can be used to determine the relative positions of objects and the direction of light. Reflection. Reflection occurs when light waves bounce off a surface and change direction. When light hits a smooth and shiny surface, such as a mirror or still water, it undergoes specular reflection, where the angle of incidence is equal to the angle of reflection. Diffuse reflection happens when light interacts with a rough or uneven surface, scattering in different directions. Reflection is responsible for allowing us to see objects that do not emit light directly, as it bounces off surfaces and into our eyes. Luminous. Luminous objects are those that emit their own light, either through chemical reactions, heat, or other processes. Examples of luminous objects include the sun, light bulbs, and stars. Luminous objects can be seen in the absence of external light sources because they generate their own illumination. These objects can create both light and shadows, depending on their interaction with other objects in the environment. Transparent, opaque, translucent objects. Transparent. Transparent objects allow light to pass through them without significant scattering or absorption. When light encounters a transparent object, it passes through in a straight line, and objects on the other side can be clearly seen. Examples of transparent materials include glass, clear plastic, and clean water. Opaque. Opaque objects do not allow light to pass through them. When light hits an opaque object, it is either absorbed or reflected. As a result, objects on the other side of an opaque object cannot be seen. Examples of opaque materials include wood, metal, and thick paper. Translucent. Translucent objects allow some light to pass through them, but they also scatter or diffuse the light as it passes through. This scattering causes the light to be transmitted in different directions, making objects on the other side appear blurred or hazy. Translucent materials partially block the passage of light. Examples of translucent materials include frosted glass, wax paper, and certain types of plastics. What exactly are shadows? Shadows are dark areas that are created when an object blocks the path of light. When light from a source, such as the sun or a light bulb, encounters an object, it cannot pass through that object. As a result, the area behind the object, where the light is obstructed, appears dark in comparison to the surrounding areas that receive direct light. Shadows are formed due to the nature of light traveling in straight lines. When an object intercepts the path of light, it prevents the light from reaching the surface or area behind it. The object acts as an opaque barrier that blocks the light, resulting in the formation of a shadow. The size, shape, and intensity of a shadow depend on several factors, including the position and orientation of the light source, the size and shape of the object casting the shadow, and the distance between the object and the surface where the shadow is formed. Shadows can vary in length and direction as the position of the light source or the object casting the shadow changes. Shadows are integral in our perception of depth, as they provide a visual cue about the relative position and distance between objects and their surrounding environment. They also play a crucial role in various fields, such as art, photography, and cinematography, as they can be used creatively to enhance compositions, create contrast, and convey a sense of realism. Pinhole camera. A pinhole camera, also known as a camera obscura, is a simple optical device that uses a small aperture or pinhole to create an image of the outside world. It is based on the principle of light traveling in straight lines. The pinhole camera creates a unique and distinctive aesthetic. The images produced are often characterized by a large depth of field, where objects both near and far appear relatively sharp. However, due to the small aperture size, pinhole cameras typically require longer exposure times, making them better suited for still or static scenes rather than fast-moving subjects. Pinhole cameras can be a fun and educational way to explore the basics of photography and optics. They demonstrate the fundamental principles of image formation and can inspire creative experimentation with different box sizes, pinhole sizes, and exposure times to achieve various artistic effects. Why never ever look directly at the sunlight? Looking directly at the sun, especially during periods of intense sunlight like midday or during a solar eclipse, can cause severe damage to your eyes. Here are the reasons why you should never look directly at the sun. Intense light. The sun emits an extremely high amount of light, including invisible ultraviolet (UV) radiation. Staring at the sun can overwhelm the light-sensitive cells in your eyes, including the retina, which is responsible for vision. Damage to the retina. The retina is a delicate and vital part of the eye that converts light into electrical signals, allowing us to see. When you look directly at the sun, the intense light can damage the cells in the retina, leading to permanent vision loss or a condition called solar retinopathy. No pain warning. The danger of looking at the sun lies in the fact that it does not cause immediate pain. Unlike other sources of intense light, such as a bright lamp or laser, the sun's brightness can trick your eyes into thinking it's safe to stare at. By the time you realize something is wrong, it may already be too late to prevent damage. Temporary and permanent vision problems. Looking at the sun for even a short time can cause temporary vision problems, including blurred vision, sensitivity to light, photophobia, and afterimages or spots in your visual field. In more severe cases, the damage can be permanent, resulting in partial or total blindness. Solar eclipses. During a solar eclipse, when the moon partially or fully covers the sun, it becomes even more dangerous to look at the sun. The moon does not block the harmful UV radiation, which can still damage your eyes. It is essential to use proper solar viewing glasses or other safe methods to observe a solar eclipse. To protect your eyes from sun-related damage, remember these guidelines. Never look directly at the sun with the naked eye, even if it appears dimmed during a partial eclipse. Use certified solar viewing glasses that are specifically designed for safe solar observation. Use proper solar filters or telescopes with solar filters recommended by experts for direct sun observation. If you are unsure or do not have appropriate equipment, seek guidance from reputable sources or local astronomy organizations for safe solar viewing methods. Protecting your eyes from the sun's harmful rays is crucial for maintaining good vision and eye health. Mirrors and reflection. Mirrors and reflection are closely interconnected. Mirrors are objects that have a smooth, polished surface, typically made of glass with a reflective coating, that can produce clear and accurate reflections of objects. Reflection is the bouncing back of light rays when they encounter a surface. When light hits a mirror, it undergoes specular reflection, meaning that the angle of incidence, the angle at which the light strikes the mirror, is equal to the angle of reflection, the angle at which the light bounces off the mirror. There are two primary types of mirrors, plane mirrors and curved mirrors. Plane mirrors. Plane mirrors have a flat, smooth surface. They produce virtual images, which are formed behind the mirror and cannot be projected onto a screen. The image formed in a plane mirror is laterally inverted, meaning it appears reversed from left to right but retains the same depth. Curved mirrors. Curved mirrors have a curved surface, which can be either concave, curving inward, or convex, curving outward. Concave mirrors converge incoming light rays, whereas convex mirrors diverge light rays. Depending on the type of curved mirror and the position of the object, they can produce both real and virtual images with various sizes and orientations. Thank you for watching. Please subscribe to my channel for more videos.